and thanks for joining this roundtable discussion. And we're going to talk about the reference architecture used to event-enable legacy core banking systems. And my name is Aiken, and I look after the technology partnership for Solace, and I have been kind of an architect in the banking sector for many years and designed a few banking platforms with the event-driven architecture being at the core. And I would quite like to share the experience here with you. And let me go around the table for my guests to introduce themselves. Fran, do you want to go first?
Yeah, thank you. So I'm Fran Parras, senior pre-sales manager in Europe for Boomi as well, and more or less like Aiken and Nori. Half of my life, working on banking and financial services institutions across the globe as well.
Cool. And last but not least, Ori.
Yeah, hi. So I'm Ori Bar based in Denmark, and I'm leading the customer success of OpenLegacy.
Great. Okay, so today we'll be discussing around this reference architecture, as you guys can see here on the screen, and to address a particular but a very common challenge that banks are facing. So you got your legacy, typically mainframe systems on-prem and containing a critical kind of, let's say, customer data, for example, that you want to share with your digital banking platform in SaaS, in the cloud environment, and then orchestrate the business flows across those platforms, actually between those platforms. So a typical use case is the omni-channel payment solution, right? And the first challenge banks are facing is how to unlock your legacy assets, where building APIs around them has traditionally been very time consuming and resource consuming. So Ori, based on your experience in the industry, and how do you tackle that?
Thanks, Aiken. This is actually an excellent question. So we experience many enterprises really struggling with the complexity of the legacy environments. So that can be all kind of mainframe of different flavors, S400, Unisys, Micro Focuses, Oracle, and others, but also all kind of databases and queuing systems and all the ERPs. And this is complex, right? And this complexity actually prevents customers from reacting to the current business demands. They're just moving too slow to be part of this new modern API economy. So we actually see a clear need for a solution which is providing cloud-native, microservice-based APIs to access the old stuff in the new way. So automation is very important. So things need to be done faster and more efficient and more structured, because APIs are being used over and over again. And normally you're saying, when things are handcrafted, that's what you relate to quality. Unfortunately, when you talk about APIs, this is not the case, right? APIs being created automatically are very standard, very clean, very efficient, and the quality is according to this. And the target is actually building an API factory, right? How do you take these massive core and legacy systems and actually build an API factory, allow it to expose this functionality to the outside? We look at scalability. So everything needs to be scalable, right? So we see different demands. We had an example with COVID right now, where one of our customers was struggling with scalability, and we had to solve it by moving to microservice architecture. There are many other things, but scalability is really a key here. If we also think about other things which are really kind of important to our customer, you also have the ability to reduce the required skills, right? So very often COBOL programmers are hard to find. People that know the legacy systems are kind of long gone. How do you actually expose the system without being system experts, without knowing kind of the heart of the system? So the last thing is not being intrusive, right? Because these systems are old and complex, a customer would like to access them to create API without doing changes, without increasing the risk. So this demand is kind of a cornerstone of what we're doing at OpenLegacy, and it's cornerstone of our strategy and offering.
Very nice. Thanks, Ori. And so now we have unlocked the legacy data and then kick off the whole, API adoption journey. So, Fran, could you share with us what are the key considerations, going through this journey of bridging between legacy system and the public and private cloud, for example?
Yeah, thank you, Aiken. I think it's several aspects here, right? For one side, what we have as well is or at least the large institutions, they have a lot of experience on the security aspect of the mainframes, the on-premise systems that they have, and also they have experience as well on the private cloud, right? Now, when we are talking about the public cloud, this is slightly more challenging, and sometimes it's more complex for those different organizations starting to adopt that specific journey, right? So in that sense, it's really important for them as well, starting to think, well, how we can leverage the power of the public cloud, right? But more important, obviously, through a governance and secure framework as well. And this is where, for instance, we can start in as well to enable options like a service mesh in such a way, using those different EDAs, right? Event-driven architectures, you can help them out to starting to sort it out, really complex problems in a simplest way, right? And this is where, in this case, right, this specific solution is really good because you don't need to be bothered anymore around all those different barriers or traditional barriers that you have in the past.
Yeah. Thanks, Fran. So you mentioned about the event-driven architecture just now, and yes, adopting EDA could be daunting. When banking environments are so complex and often located in multiple regions across the globe, right? You mentioned public and private clouds, and this is exactly where the event mesh layers comes in. So event mesh, as you can see here, like on the diagram, is basically a network of event brokers that sit in the clouds or on-prem, data centers, or at the edge of IoT gateways, if you have some kind of IoT use cases as well. And to move those data, could be IoT data, could be transaction data like payment data, could be a payment request, could be a payment response, or events, we call it, or in fact, more than often we see service invocation calls. For example, a RESTful call is actually a piece of event or piece of message, right? So this concept is very similar to the kind of service mesh you may have heard about it before, where it supports the communication between the different type of messaging patterns. For example, request response that I mentioned, which is very RESTful, and then talking to the kind of RESTful type of microservices, or the event mesh enable more async pops up type of event, event-driven microservices. That's how we call it. So the event mesh actually routes those on-prem legacy data, to their kind of consumers in clouds and trigger the business flows in kind of different environment, as what Fran said. So this business process could be the usual, synchronous business flows, which in a payment terms, you got the whole we call it the fast path synchronous kind of process, right? Payment initialization, handled by a payment init microservice, and then validated microservice, and then funding, all very sequential and synchronous. But on the other hand, you got a whole set of, we call it the asynchronous microservices, also listening to the same piece of data, microservices such as cross-sell, upsell, or kind of calculated risk and audit of your payment process at each stage of the the payment transaction. And of course, there's a whole insights, for example, AI or machine learning type of analytics microservices that you can apply, and then listening to those same piece of data in real time, and then apply the most kind of needed pieces where you want to improve customer experiences, for example, or you want to improve the operational efficiency in general. So this is where the banking really gaining their kind of a competitive advantage over other banks when they can really handle this type of async data. And so the event mesh is great, right? You heard, you can see that, but there's so many events and data flowing between the systems, and then of course across regions, and then you could become very messy very quickly, because pops up pattern by nature is very decoupling, very kind of not kind of point to point coupling. So the difficulty here is to apply a governance. That's where the event portal comes in. So where if you look at online, like event portal is very similar to API portal, where this piece of tooling can apply a very central governance model from design time to design your event-driven architecture application to the kind of runtime where you actually want to monitor the whole kind of events, how they in and out of the different environment, different systems. You even want to have like we call it the event lineage over, the applications over your event mesh landscape, right? So this is what event portal is for. Right, so this is the event-driven architecture side of the toolings and technologies. Let's talk about the architecture where, will meet the modern days payment requirements. One of the biggest challenges in the payment industry is the regulations and the multiple jurisdictions, especially when it goes across, different regions, APAC or EMEA or North America, right? So Fran, could you help us to understand how do we, take on this challenge with this architecture here?
Okay, yeah, thank you so much, Aiken. So it's really interesting, right? Because the regulations, they are really, really complex, right? So you have regulations, obviously, you can imagine in country level. You have, regulations as well, let's see in Europe as well, right? In European level, right? And so on. And also you can have potentially regulations between countries as well. So this type of solutions will help us as well to literally, right, being able to understand potential problems on the payments beforehand. We can as well start to tackle possible data quality problems, right? So remember, in this case, the payments are being initiated through legacy systems, right? So potentially they can have still, challenges around the quality of that data. So through the event nest, we can starting to detect those different challenges and starting to address in near real time those different challenges. Obviously, worst case scenario, you can request manual intervention from one agent from the bank or from the the target bank. But the idea here is try to reduce that friction, right, and enable that specific data governance framework on top of the payments. That is one of the biggest benefits on this scenario. And bear in mind, even though we have still Swift and and empty messages. Today with the ISO, the main goal is trying to obviously reduce those different challenges, but both systems will still living together. So you will have banks using MT, you will have banks using ISO, right? So still certain discrepancies that can be being addressed through this specific approach.
Yeah, thanks, Fran. And I think you highlight that point as well. Traditionally, payments are really initiated by legacy systems and core banking systems. So the underlying technology is very kind of legacy based, and there's a big headache of dealing with the different formats, right? Old and new formats and standards across the system boundaries. And then, so Ori, could you share with us your experience in bridging, these gaps? Yeah.
Thanks, Aiken. Yeah, I definitely can, and that's practically what we do for living, right? So OpenLegacy can seamlessly parse and understand legacy metadata. So what we're really good at is hooking into all kinds of systems, and that could be all kinds of mainframes, AS400s, and core banking systems, and ERPs, and you name it. We have the way to understand the data, we have the way to understand the business logic, and this way we can actually expose it in a very easy to use and consume manner that can either go to Solace, I can bring to Boomi, I can go directly to Boomi, and so on and so forth. But we like to talk about ourselves like kind of translating different language which is old and complex and so on to something which is common and can be easily used. And the more complex the system is, the happier we are, right? So we connect to everything which is old and complex, and we are extending visibilities each and every day.
Yeah, but how does your approach differ from the kind of old SOA based layer, which is very commonly used in the current banking landscape?
Yeah, that's an excellent question, because we are not a layer, right? So SOA is based on some kind of layer which is taking care of all the integration. OpenLegacy is a design time framework, right? So we know how to build non-intrusive, flexible, decoupled microservices. These microservices contain everything the customer needs to do the integration. These microservices play naturally within the Boomi atoms. They can be deployed on any environment. So it has flexibility of getting the information directly from the source rather than having all kinds of layers in between. At the same time, we do not have any runtime. Everything you need to have is within the microservices.
Great. Thank you, Ori. So just to summarize here, right? So based on the diagram we see on the screens, we got the OpenLegacy layer here. Sorry, not layer, as already said, the OpenLegacy technology here, actually converting the kind of legacy data or legacy processes in this case to unlocking those data and then stream it out into kind of Solace event mesh, where you start to share with the different applications in cloud or on-prem or different type of clouds, streaming those data, or in fact, as I mentioned, the service invocation calls into those environments where Boomi can orchestrate the business flows in those environments in real time. And this is also a fan out situation here, right? Same piece of data can trigger different processes in different places. So not only, for example, the digital banking with the kind of open banking requirements based on the API-driven kind of technology, not only triggering those kind of platforms in cloud, but also at the same time, as we mentioned, a whole load of asynchronous type of microservices also listening on this, in this event mesh and capturing the data that they need to provide a better, for example, real-time customer experience. And of course, I mentioned, about the operational efficiency as well. So overall, you see, this is we call it the omni-channel payment platform, is because the kind of different channel coming in, whether it's coming in on-prem or whether it's coming from in a cloud environment, whether you can see here some of them, they are the aggregated type of we call it the super app kind of architecture, where you got a payment request from all different kind of apps and all aggregated into one place. And also maybe from the connected cars environment, smart city environment, they all got lots of payment requirements, and all those requests coming in to this this architecture, and then the architecture actually can really kind of taking in those requests and then respond to the customer in real time, right? So this is the beauty of that architecture. We got a couple of minutes left, and Fran and Ori, do you have anything to add to this reference architecture?
Well, in this case, right, from my point of view, and coming back with your specific, comments before around all those different type of payments and new services that all the different organizations, they are starting to enable as well. I think the beauty of this solution is, so we can still using that specific legacy business logic, if you want to call it, right? That business logic is still gold dust for all those different organizations, and will take long as well to have that specific business logic outside of the mainframe, right? So being able to leverage without friction that business logic and without resources with those different skills, I think is really, really powerful.
Yeah, agreed, totally. Ori, anything from you?
Yeah, exactly. I fully agree. So actually, if you look at transformation of legacy, that's a process that takes many, many years. In the meanwhile, customers are pushed to serve business needs, right? And this is a very smart, very clever, very fast architecture to do this. On the other hand, everything we create and build here is not a waste, right? Because once you actually move to the future platform, many things still remain, right? The logic remains, the consumer of the APIs and service mesh are the same, and so on and so forth. So this is actually a very elegant way to make sure while you're transforming, you keep on serving your business and your business requirements.
Yeah, I think Ori highlighted a very important point about future proofing of this, architecture, is that once the data is shared within your event mesh, you can actually stream those service invocation calls and event data to whole bunch of future adding SaaS offering, whether it's SAP S/4HANA or any other kind of ERP or CRM system that you want to use. So this is a very flexible and also kind of future-proof kind of technology or architecture here. Perfect. Right. Thank you very much, guys, and the audience here also for the interesting discussion. So feel free to get in touch if you want to know more about this solution, or better, if you want to actually see a demo, just let us know. Thank you very much.
Thank you.
Thank you. Actually, before you guys go, there's a question I can see. Sorry, I just noticed a question. The synchronous type and async type, is it defined or configured when the consumer subscribed themselves, right? So the I'll give it a go, and then feel free to jump in, guys. So the synchronous type and synchronous or asynchronous type is more of a kind of a communication pattern, right? So you the typical synchronous type, for example, RESTful calls, it can be implemented by a async type of mechanism like a messaging. So you can fire a RESTful message for request, and that message get handled by a subscriber, which is listening to that request, and then complete the request and put the response back to the event mesh. So the requester and the response, that they never really talk to each other point to point, but they're all actually going through that event mesh in the middle. But because they have an ID actually related, so the response know how to get back to the kind of requester. So this is how we actually implement the kind of typically synchronous process into by a synchronous mechanism, which make it much more scalable, because you can fire like a request in a very high speed, high throughput way, and then respond kind of in an asynchronous way, right? So this is not about the actual technology. If you're using event driven or event mesh technology, it's all based on the messaging mechanism. So a publisher and a consumer, and then you got the message or events in the middle connecting them. So anything to add, Fran or Ori?
I think that's complete.
Yeah, I think it's absolutely complete. Yes.
Okay, cool. All right. So thank you so much, guys, and I'll see you next time.
Thank you.
Thank you.
Bye-bye.
Bye, Fran. Bye, Ori.